Okay, let us start now. Okay. So today we will discuss some other problems related to GCD, greatest common divisor. Okay. So in the last class we have discussed this theorem. This is very important theorem. If D is the GCD of A1, A2, N, then there exist integers. You will find integers x1, x2, xn such that D can be written as a this expression, this linear combination A1, x1 plus A2, x2 plus that plus An, xn. Now we will discuss this theorem. If D is GCD of A1, A2, An, then integer D1 is a common divisor of A1, A2, An if and only if D1 divides D. Okay. So let D1, we will start with this one. D1 divides D. Okay. Then we will prove that D1 is a common divisor of D. So D1 divides D since D equal to GCD of A1, A2, An. So D divides each AI. I equal to 1 to n. GCD है तो सब नंबर को डिवाइड, it will automatically divide all numbers. इसी को तो GCD कहते हैं, ठीक है? And then it is greatest. So D equal to GCD of this. That means D divides all AI. And since D1 divides D, so therefore D1 also divides. D1 divides D and D divides AY. That means D1 divides AI. Yeah, this combining these two. D1 divides D and D divides each AI. So here comparing this and this, you can say D1 divides each AI. So that means D1 is a common divisor of A1, A2, An. Now second, conversely, let D1 is a common divisor of A1, A2, An. And since D is the GCD of A1, A2, N, by theorem 7, there exist integers x1, x2, xn such that D equal to A1, x1 plus A2, x2 plus An, xn. And since D1 is a common divisor, so D1 divides this expression. D1 is a common divisor of this. Then we know that D1 divides this A1, x1 plus A2, x2, and this is our this one D. So therefore D1 divides D. Means D1 divides this and the value of this is our D. So D1 divides D. Now next theorem, theorem 9. If A1, A2, An are non-zero integers, okay, it is in page number 26. And if D1 equal to A1, okay, if A1, A2, An are non-zero integers, and if D1 equal to A1, D2 equal to GCD of D1, A2, D3 equal to GCD of D2, A3, and so on. And lastly, Dn equal to GCD of Dn minus 1, An. Then we need to prove that Dn is equal to GCD of A1, A2, up to dot An. If this satisfies, then Dn is the GCD of A1, A2, An. We can prove this theorem. We shall prove it by mathematical induction. The result is true for n equal to 2. You see, D2 equal to GCD D1, D equal to GCD of D1, A2. Okay, and this is equal to GCD of D1 is our A1. D1 given as A1, you see, D1 given as A1. So, and second, you see D2 equal to GCD of D1, A2. And if you take in place of D1 as A1, so D2 equal to GCD of A1, A2. So this is true for Therefore, that is D2 equal to GCD of A1 comma A2. So that means it is true for n equal to 2. Now let it be true for n equal to r. That is dr equal to GCD of A1 comma A2 comma AR. We will prove that r plus 1, n equal to r plus 1. This is equation number 1. Dr equal to GCD of A1 comma A2 comma AR. Now claim dr plus 1 equal to GCD of A1 comma A2 comma AR plus 1. We need to prove this. Dr plus 1. Then by induction, our theorem is proved. So we need to prove dr equal to this. Let ER plus 1 equal to GCD of A1 A2. We suppose this ER plus 1 equal to GCD of this. तो हमें क्या प्रूव करना है? We need to prove that dr plus 1 equal to ER plus 1. Okay? If ER plus 1 equal to, let suppose ये हमने सपोज किया है GCD, ठीक है, तो ये दोनों इक्वल होना चाहिए, ये हमें प्रूव करना है. So now by assumption, dr plus 1 equal to GCD of dr comma AR plus 1. ये तो given assumption है. dn कैसे डिफाइन है? dn equal to GCD of dn minus 1 into this. So therefore dr plus 1 equal to GCD of this. Since er plus 1 divides this, okay, er plus 1 हमने ये we take er plus 1 as the GCD of this. So ER plus 1 divides A1, A2, AR plus 1. Okay. GCD, it means it is also a common divisor. Okay. So ER plus 1 divides A1, A2, AR up to AR plus 1. So we can take it up to AR. Okay. DR plus 1 divides this R plus 1 number. So it also divides this all R plus 1 number. So it also divides all these R numbers. एक छोड़ के बाकी सबको भी divide करें. It will divide all. So this implies ER plus 1 divides dr by theorem 8 from 1 and D. From 1 and D. What is 1? dr equal to this. So dr divides all ER plus 1 divides dr from 1 and D by theorem 8. ER plus 1 divides dr. dr divides A1, A2, AR, you see. And also ER divides A1, A2, AR. So ER plus 1 equal to dr. It is common divisor. ER plus 1 is the common divisor of this. Okay. और dr क्या है? GCD of this. Okay. तो common divisor mass divides GCD, greatest common divisor. So ER plus 1 divides dr. ये equation number. This is your relation E. Similarly, some other relations from C and E we get ER plus 1 divides AR plus 1 and ER plus 1 divides dr. This implies ER plus 1 divides GCD of dr comma AR plus 1. This implies ER plus 1 divides dr plus 1 by assumption. And this is equal to dr plus 1 basically. GCD of dr comma AR plus 1 is equal to d of r plus 1 by a given assumption dr plus 1 equal to GCD of dr comma AR plus 1. So ultimately we prove that ER divides dr plus 1. This is equation number. This is relation 2. Okay. Similarly, we will prove that another dr plus 1 divides ER plus 1. Then since these two are positive, we are talking about GCD. Okay. So that means we are considering both are positive. So if anyone each divides other, okay, then this two must be equal. Okay. If A divides B and B divides A, then and both are positive, then the only possibility both quantity are equal. Okay. So from B, you see dr plus 1 divides dr. From B, dr plus 1 divides dr. Yes. Is it GCD of these two numbers? So GCD means common divisor also. So dr plus 1 divides dr. And dr plus 1 divides AR plus 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1 So this is the common divisor of this and this. Now from 1, dr divides each ai, y equal to 1 to r. Okay. So from f and g we get dr plus 1 divides ai, I equal to 1 to r, r also and r plus 1 also. ar plus 1 अलग से है यहाँ, you see ar plus 1 यहाँ है और r तक यहाँ है, ठीक है. So therefore dr plus 1 from a dr plus 1 divides er plus 1. So from 2 this is 3 relation from 2 and just simple calculations up, see the all equations one by one and using one another. Okay, no problem. These are very simple calculations. You have to just comparing the relations. From 2 and 3 we get dr plus 1 equal to er plus 1. Therefore er plus 1 is dr plus 1. So dr plus 1 is the GCD of a1, a2, and this completes the theorem. Now there are some small results. If a, b, k are integers, then show that GCD of ab equal to GCD of a plus kb comma b. Okay. If a, b, k are integers, then show that GCD of a comma b equal to GCD of a plus kb comma b. These two quantities, here number is a plus kb and here is b. And here is kb. We can show that these two GCDs are equal. a b के जो GCD है a plus kb and b के भी GCD दोनों equal है. So now we will prove it. Let d equal to GCD of ab and दूसरे के GCD मान लीजिए d1. Our claim we need to prove that d equal to d1. और ऐसे कैसे प्रूव करेंगे? एक बार d divides d1 शो करेंगे, एक बार d1 divides d, but both positive, so ultimately we will prove d equal to d1. Okay, so you see 1 and 2, we suppose these two, d is the GCD of ab and d1 GCD of these two. So 1 implies relation 1 implies d divides a and d divides b. Okay, so if d divides b, when d divides b, then we show that d divides kb also. So, we will get here, we will get d divides a and d divides kb. मतलब किसी भी मल्टीपल को भी it will divide some other multiple also. b को divide कर रहा है तो b के मल्टीपल को भी divide, it will divide. So combining these two, we can find here d divides a and d divides kb. This, so d divides a plus kb, they are sum also. कोई भी any linear combination को भी it will divide again. ये already हम पढ़ चुके हैं कि if some number divides a and if that number divides b, then ab के कोई भी linear combination को it will divide, that number will divide. So इन दोनों के linear combination ये हो गया, a के साथ 1 into a plus ये kb. So they are sum, d divides they are sum, simply they are sum. Okay, so and d divides b, it is given to d divides b here, you see from 1. So we proved here d divides a plus kb and d divides b. Okay, तो इसका मतलब क्या हुआ, d इन दोनों के क्या है, a plus kb और b के common divisor. You see d is a common divisor of a plus kb and b. Okay, a plus kb और b, a plus kb comma b, इन दोनों के कॉमन डिवाइजर हो गया d. और इन वी टेक हियर d1 इज द जीसीडी ऑफ d. इसका मतलब इन दोनों के ग्रेटेस्ट कॉमन डिवाइजर वी हैव टेकन ऑलरेडी d1 और d को हमने कहा कॉमन डिवाइजर ऑफ दिस टू. इसका मतलब एक कॉमन डिवाइजर है d और d1 ग्रेटेस्ट कॉमन डिवाइजर है, तो इन दोनों में आपस में रिलेशन d मास डिवाइड्स d1. जो कॉमन डिवाइजर है इट विल डिवाइड्स ग्रेटेस्ट कॉमन डिवाइजर, तो d मास डिवाइड्स d1. They say relation is this is A. Similarly, d1 divides a plus kb and divides b implies d1 divides b. d1 divides b implies d1 divides kb. So d1 divides a plus kb, ये तो given है, और यहाँ से हमने ये d1 divides b से ये we calculate this d1 divides kb. So now combining these two, d1 divides a plus kb minus kb also. Okay, this quantity minus this, d1 divides this quantity, d1 divides this quantity, their difference को भी divide, it will again their difference. D1 divides their difference also. Okay, so and you see, if we take difference, then KB plus KB minus KB, it will cancel. Only D1 divides A. So what we get? D1 divides A, we prove D1 divides A, and here D1 divides B. So we get D1 divides A and D1 divides B. Implies D1 is a common divisor of A and B. सिंपली हम यही कह रहे हैं कि D1 इन दोनों नंबर को डिवाइड करना है. इससे हम GCD के नहीं कह सकते, लेकिन इतना कह सकते हैं कि दिस नंबर जो दोनों को डिवाइड कर रहा है उसको हम कॉमन डिवाइजर नाम दे सकते हैं, बट वी आर नॉट श्योर दैट इट इज GCD और नॉट. Okay, so we reach up to the conclusion that D1 is a common divisor of A and B. But A और B के GCD क्या लिया? But D is the number one, relation one, where we suppose that D is the GCD of AB and D1 is the GCD of. So AB के GCD we take as D, and here we get D1 as a common divisor. So common divisor will must divide the greatest common divisor. So in this case, D1 common divisor of AB and D is the greatest common divisor of AB. So D1 must divides D. So this is second relation B, or for A relation A is D1 D divides D1, and here relation B is D1 divides D, and दोनों D1 all are GCD and we are considering positive numbers. So D equal to D1. No other option. एक दूसरे को डिवाइड कर रहा है तो उसका मतलब both the numbers are equal. You see here, not small result. Another. If A divides BC and GCD of AB equal to 1, then A must divide C. Okay. If A divides BC and GCD of AB equal to 1, then A must divide C. इस प्रोडक्ट को डिवाइड करता है और इसके साथ A और B के GCD 1 है, उस केस में A will must divide C. How it is? You see. Assume that C not equal to 0. Okay. Assume that C not equal to 0. C0 any number A will divide 0. Okay. कोई भी नंबर 0 को डिवाइड करता है. Okay. So assume that C not equal to 0. Okay. If C0, then there is nothing to prove. It is BC will become 0. There is nothing to prove. So and GCD of AB equal to 1 given, then by that theorem 1 can be written as linear combination of these two for sum x, y belongs to y. यहाँ देखिए for sum जहाँ GCD को आप इक्वल लिखते हैं वहाँ लिनियर कॉम्बिनेशन जो लिखते हैं वो एक्स वाई आर्बिटरी नहीं होता. फॉर सम एक्स एंड वाई, वहाँ जो फॉर सम x1 x2 xn, यहाँ फॉर सम 2 है तो फॉर सम xy, 3 हो तो फॉर सम xy z, इसी तरह. ओके, सो GCD 1 इक्वल टू 1 कैन बी रिटन, ये GCD 1 है तो वी नो दैट GCD कैन बी रिटन एज अ लिनियर कॉम्बिनेशन ऑफ द नंबर्स ax प्लस by. नाउ c से मल्टीप्लाई कर दीजिए, acx प्लस bcy इक्वल टू c. Okay, so since A divides ACX, since A divides ACX and A divides BCY, देखिए कैसे है, A divides ACX, यहां हम कह सकते हैं ACX कैसे कह सकते हैं, यहां तो A मौजूद है, C इंटू एक्स कोई और उसके मल्टीपल हो गया, सी एक्स टाइम मल्टीपल्स. So कोई भी नंबर 2 divides 2 into any number. Okay, so A divides A into CX and also A divides BCY, यहाँ given है A divides BC, उसको और कोई मल्टीपल कर लीजिए, BC को और बड़ा मल्टीपल रख लीजिए, Y के मल्टीपल, ये सब इंटीजर है Y है. Okay, so A into BC of Y, A divides ACX, A divides BCY, A must divides ACX plus BCY, दोनों के सम को भी डिवाइड करेंगे. 1 into this plus 1 into this हो गया. A divides this and A divides this, तो A divides this into plus this 1 1 रख लीजिए. ACX plus BCY and ACX plus BCY is your, you see here it is C. This implies A divides C. So you can ठीक, यहाँ बस वो theorem यूज हो रहा है आपको, उसका वो मेन है कि GCD can be written as a linear combination of, जो भी जिसका GCD है, जो जितने नंबर के GCD है उन सबके linear combination with sum for sum इंटीजर्स x y डैश, वहां से एक एक नंबर के साथ एक एक इंटीजर्स की प्रोडक्ट एंड देयर सम, इसे आप इस फॉर्म में लिख सकते हैं. Now if a divides c and b divides c with GCD of a b equal to 1, then ab must divide c. Okay, this is also very interesting result, small result, but this will we will use very oftenly in the coming lectures. Okay, so given GCD ab equal to 1, this implies 1 can be written as the linear combination of these two, ax plus by. Okay, for some xy in z. Okay, so now multiply cx plus bcy equal to c. Okay, also a divides c given as, so c equal to a into some am for some m integer. B divides c given, that means c can be written as bn for some n integer. Okay, अब now putting this, ये c है, यहाँ c है, c के वैल्यू पुट कर दीजिए. ओके, c इक्वल टू बी एन यहाँ पुट कर दीजिए, जहां a है वहां बी एन और जहां b है वहां am वाला पुट कर दीजिए. अब यहाँ am रखेंगे तो नहीं होगा. ओके, ये थोड़ा सा यहाँ मैनिपुलेट करना है आपको. यहाँ c के वैल्यू आप दोनों जगह रखना है, तो c के वैल्यू यहाँ जहां a है वहां b वाले पार्ट रखिए बी एन, और जहां b है अवेलेबल वहां. Okay, so this implies a b n x में रख दीजिए, फिर you will get this one. Now a b common, nx plus my. Okay, this a b divides this because a b common है दोनों पार्ट में. Okay, so this implies a b divides c. Okay, we will discuss in the next class this Euclidean algorithm. Okay, so this is all about for today's lecture. From next class I will start Euclidean algorithm. Okay.
Yes,
Okay.
yes, sir.
Okay.